In today's class, we're going to take a look at a common application of the addition formulas, which is sometimes called the wave function. And it's basically when you take a sine and a cosine function and you kind of merge them together. And the analogy with actual waves, like waves in the ocean or sound waves, I guess, is quite useful because when you take two like waves in the ocean, when they come together, they don't sort of just bounce off each other, right? They kind of merge and form a kind of third new wave, I guess. Similar here. So we're literally going to take like a sine and a cosine function and just add or subtract them together and figure out what that new wave, that third wave, kind of looks like or what it becomes. We're going to work this example in a moment, but this maybe kind of illustrates what we're looking at. We've got a sine and a cosine function. There could be numbers in front. We'll chat about that in a second. But you're basically merging them in some way. We could be adding them, we could be subtracting them. But the important point is you're taking two of them and merging them. When you do that, you're going to get either a sine or a cosine function as the kind of third wave. This is the merged version of these two. And the analogy is quite useful as well because sine and cosine make graphs which are wave-like. So the result is this kind of third wave. So in general in this topic, we're taking like a sine function. So instead of just calling it sine x, let's call it a sine x because there could be some multiplication of the sine function, so some number in front basically. So a sine x plus b cos x. And we want to merge those together to either form a sine or a cosine. So I'll just write that maybe as sine or cosine of some x plus or minus some value, which I'll call alpha. So in this case over here is an a. I'm just going to use an alpha because I put an a here. And some number in front as well. So when you merge these, you're going to get some new number in front and you're going to get some number in here. And if you remember, if you're already familiar, that is, with graph transformations for sine and cosine functions, this format here just means a left or right shift. So a horizontal shift. So a plus moves it to the left, which is kind of counterintuitive, and a minus moves it to the right. So what we're saying here is we're taking these two original functions, we're merging them by either adding or subtracting, and we're getting some multiplication of a sine or a cosine. This would be the amplitude value, by the way, like how high up and down the graph goes, and some left or right shift. So thinking of these algebraically, this is kind of the scenario. Thinking of these graphically, then you've got your original sine wave, which kind of goes like that. You've got a cosine wave that goes like that. If you merge them together, you're going to get some variation of one of these graphs. And that's essentially what we're trying to do in this process here. So questions in this type will be set up in a way that might say something like, write this function in the form k sine x minus a, something like that. And essentially this question comes down to finding the k and the a value. That's what we're going to achieve by working through the algebra. Okay, so the main thing about this question type is that this here, if you're already familiar with the addition formulas, which you probably should be if you're taking this class. If you're not familiar with those, maybe check out the class on that first. But this guy here can be written in the format, or is in the format of one of the addition formulas. So what we're going to do with this question, we're going to start by expanding that using the addition formula. So I'm just going to write another line here where we do that. If you're not sure about the addition formulas and you're not ready to go check out the class on that, just maybe look them up. But basically it's a formula for expanding this. So if we did that, we would get k sine x sine, no, that's wrong. Take that out. So we would get k sine x cos a minus k sine a cos x, something like that. So what's quite useful with these questions is to spin these around so that the x term comes second, because x is our variable here, and when we're working with variables and what is essentially just a number, you know, we would never write like x 4, for example, we would always in algebra write 4x. So just bear in mind that here, this is essentially a number, so is the sine A, and the x is your variable. So I'm just going to go ahead and take a line to spin those around. You don't have to do that, but I find that's probably quite a useful move for the next line of working. So the second one I'd already written in that form. With the addition formulas, if you've already used those, you'll know that it doesn't really matter which way around you write these because they're a product. It doesn't matter which way they go. But for this line of working, we're going to try and get them in some kind of order. So what we're doing now is we're saying that this was equal to this, and I've just expanded this to give me that. So that essentially means that that is now equal to that. So I'm just going to pull that down there to write it on the same line. So root 3 sine x minus cos x equals that there. And what we're essentially doing now at this point is matching up the left and right hand sides of this equation. So the thing that goes with the sine x here is root 3. The thing that goes with the sine x here is k sine a. So that's why I reordered the terms, so we can see the coefficient of the sine x and the coefficient of the sine x. Similarly, the thing that goes with the cos x here is it's a minus 1. So I'll just write in the 1 and say that's a minus 1. And here it's a minus k sine a. So just to kind of get those matched up, I guess. So that means that we can literally write those as equal to each other. So k cos a equals root 3. And minus k sine a equals minus 1. If there are negatives, you've got to be really careful. You can write them down in this kind of form here, but if it's both negative, if both terms are negative, you essentially can drop the negatives in that equation, but it might be an idea to write them in first. If one's positive and one's negative, you've got to be particularly careful. So keeping a close eye on your signs at that point. So a quick recap of what we've done so far. This was our starting point. We've said, right, this is in the form of the addition formula, so we can expand it like that. I then did this line of algebra just to reorder these terms to make the matching up easier. And then we've just matched it up to make these two equations. It's from these two equations that we're then going to solve to get our k and our a value. We'll start with the k value. So there's a little process for the k value, which I won't show the derivation of here, but essentially the k is given by the square root of these numbers squared and added together. That's true every time, you just got to remember that. So it'll be root 3 squared plus 1 squared. That comes from the fact, that probably looks familiar to you from Pythagoras, and it is to do with Pythagoras, but we don't really need to worry about it too much just now. Just remember that's part of the process for these questions. You'll never be asked, I wouldn't have thought, to explain where that comes from. So square root of 3 squared is just 3 because they cancel each other. 1 squared is 1. 3 plus 1 is 4. Square root of 4 is 2. So that's all just going to come out to be 2. Okay, so that's how you find the k value. That process never changes. You'll literally do those steps every time. Once we've got the k value, we then turn our attention to the a value. This one's a little strange at first, but basically what we're going to do is we're going to divide our two equations. We're going to divide this equation by this one. So that's going to look like k sine a divided by k cos a equals 1 divided by root 3. So it's quite unusual to think of dividing equations, but you can do that. That's a legitimate kind of move. In this scenario, these k's would cancel. And the reason why we've done this is there's a trig identity that says that sine over cos is equal to tan. So we can just turn that into a tan a equals 1 over root 3. Now, once you've done enough of these questions, you might find your own process for some of these steps and you might speed it up a little. So for example, you might skip that line and go straight to this line because you know that it's going to cancel to make a tan. The k's are going to cancel every time because the format's always the same with these questions. These questions, like all trig questions, can either be in radians or they can be in degrees. They can either be calculator or non-calculator. This would be, well, let's work this one in degrees, but this would be a non-calculator question probably because this is one of the exact trig values for tan. So either by using your exact value knowledge, which again, if you're not sure about that, maybe check out a class on that first. Either by using exact values or some kind of method that allows you to evaluate this, you can figure out that the A value would be 30 degrees. And that, just to quickly mention where that comes from, you get these two special trig triangles. One of them looks like this, 30 degrees, 60 degrees, hypotenuse of 2, side length of 1 and root 3. If you choose 30 to be your reference angle, this would be opposite, adjacent and hypotenuse. So opposite over adjacent, 1 over root 3 is tan. From SOHCAHTOA, tan is opposite over adjacent. So the angle we're looking for to make 1 over root 3 for tan would be 30 degrees. So that's where I'm getting the 30 degrees from. So what that basically tells us is that we've now figured out our K value, we've figured out our A value, and that is essentially what we needed to do to solve the question. We'll finish it off in a moment. Just one thing quickly to mention is that when you get to this point here, you want to think about a cast diagram. Now, in this particular question, the cast diagram is not super important, but in general, it might be important. And what you want to do with the cast diagram is go back to your two original equations here and check whether the sine or the cosine is positive or negative. So we've got cos positive, so we're going to check the two cos positive quadrants. We've got sine positive, we're going to check the two sine positive quadrants. The one with like the double check, that's the one where our A value needs to live. So quadrant 1 in this case. Quadrant 1 is 0 to 90 degrees. So our 30 degree answer is valid. If one of these was negative, you might end up with, say, a double check here, or a double check here, or somewhere else, and you would need to make an adjustment from this number here, okay? But if you've already got a bit of background in trig, you'll probably be comfortable with making adjustments on a cast diagram. If not, that's maybe something you'll just need to figure out as you work through more complex examples of this question. So now that we've validated our 30 degrees and we've got our 2, that would just tell us that this original thing here is equal to 2 sine x minus 30 degrees. What does that look like? Well, that looks like a sine graph, but it's stretched up to 2, stretched down to minus 2, so that's like the amplitude value, and it's moved 30 degrees to the right. So remember that for these transformations, a minus in the bracket there means I move to the right. So that would be a sine graph, but stretched up and down and moved over to the right. So that's the effect of merging these two functions together. So it's not an easy technique. There's quite a lot to remember. There's quite a lot going on in this question. I always think these are great questions to kind of test all the parts of your trig knowledge, because you've got exact values in there. You've got some trig identities, you've got the triangles, there's a whole bunch of stuff going on. So spend a little time working a few of these, and hopefully if you just learn the process, then you should get on okay with them.